Introduction to the mole concept. A mole is a set quantity of a substance. It tells you how many of something you have. When dealing with atoms, this number needs to be very large in order to have enough atoms be present as a visible quantity. So if I want to see a mole, or if I want to see a quantity of sodium metal, I'd have to have a ton of atoms put together in order to be able to see a visible chunk of that metal. 1 dozen eggs, we know, equals 12 eggs. When I say 1 mole of eggs, I'm talking about 6.022 times 10 to the 23rd eggs. That's a lot of eggs. That number is known as Avogadro's number, and it's basically Avogadro's number is the number of particles within a mole of a certain substance. Now in this class, we are not going to be doing any calculations using Avogadro's number. That's more for a chemistry class. We are just going to focus on the mole concept. But I wanted to bring it up here just so you know what a mole actually is and why a mole is so large. So it's so many atoms that are put together so that we have enough atoms together to make a visible clump of whatever element we're trying to conduct experiments with. So just like a dozen eggs is 12 eggs, a mole of eggs means a set quantity of those eggs, and that happens to be 6.022 times 10 to the 23rd. I could say a mole of children is 6.022 times 10 to the 23rd children. Just like a dozen children is 12 children. So very similar concept here. A mole is just a set quantity of a substance. The molar mass of any element, the mass of 1 mole of atoms of that element, is equal to the atomic mass of that element expressed in atomic mass units. 1 copper atom has atomic mass of 63.55 AMU. If you look at your periodic table of elements, if you find copper, you can see that number 63.55 rounded is the atomic mass. So 1 mole of copper atoms has a mass of 63.55 grams. Thus, the molar mass of copper is 63.55 grams per mole. So now we're starting to see that a mole can be used as a conversion factor. So calculate the number of moles of carbon in 0.58 grams of diamond. So diamond is just really compacted carbon, so we're going to work through this one. So 0.58 grams of carbon, and we're trying to get to moles of carbon. So this is what we have, this is what we're trying to get to. Just like any normal unit conversion, we start with what's given, 0.58 grams of carbon. Because we started with grams of carbon, we have to put grams of carbon on the bottom. Now we're converting to moles of carbon. Now, how do we determine what the conversion factor is here? Well, 1 mole is equal to the mass that's listed on the periodic table in every instance. 1 mole is equal to that atomic mass. So 1 mole is equal to 12.011 grams of carbon. So if you look at the periodic table, you can see the mass that's listed for carbon is 12.011. 1 mole of any substance is equal to the mass from the periodic table. So now we're going to solve this just like we do any unit conversion problem. These units cross off, we're left with units up here, and that's what we wanted to end up with. So we're going to multiply across the top, divide away the bottom. This becomes 0.58 divided by 12.011, 0.0448 moles. Calculate the number of moles of bromine in 1.22 grams. I'd like you to pause the video and try to attempt this one on your own. and then you can unpause and we'll go through it. All right, so this is what we have. This is what we're being told to turn it into. So we have 1.22 grams of bromine. Because we had grams on the top, we're going to put grams on the bottom. We're converting to moles of bromine. 1 mole is equal to the mass from the periodic table. Bromine is 79.904. So then the units cross off, we're left with moles. That is correct. That's what we wanted to end up with. So now we do 1.22 divided by 79.904. And we end up with 0.015. And we put our unit, moles of Br. So the word mole as a unit is typically abbreviated MOL. So that's what you'll see me use interchangeably throughout this course. So now we're starting with moles and we're going to mass. I want you to pause the video and try to do this one on your own, and then we'll go through it. Okay, so we're starting with 1.01 moles of chlorine. Because we started with moles of chlorine, we're going to put moles of chlorine on the bottom. We're converting to grams of chlorine. 1 mole is equal to the mass from the periodic table. So chlorine, 35.453. So the 1 goes next to the mole, the mass goes next to the grams. Whether the grams is on the bottom or top, we always put the appropriate numbers next to each other, just like with unit conversions. So now we're going to multiply by the top, divide away the bottom, which means these units are going to cross off. We're left with grams. That's what we wanted to be left with. So 1.01 times 35.453 equals 35.8. We'll round it. And grams. So now we're getting into compounds. So molar mass of compounds is a bit more complicated because instead of just pulling the mass off the periodic table, we actually have to calculate the mass of the molecule. So let's start with this. So 1.75 moles of water, and we want to know how many grams of water that is. So we have 1.75 moles of H2O, and we want to convert this to grams of H2O. So moles is on the top, moles goes on the bottom. We're converting to grams of water. 1 mole is equal to the mass from the periodic table. Well, we have to calculate this because now it's a molecule. So to calculate the mass, the molar mass, we are going to do H and O, just like we did before. There are 2 hydrogens, so we're going to put 2 times 1.008. And then there's 1 oxygen, so that's 1 times 15.999. And when we do this in our calculator, (18.015 grams. So what this means is that there's 18.015 grams in 1 mole. So now we're going to multiply across the top, divide away the bottom. So we have 1.75 times 18.015. The 1 doesn't matter, so we have 31.5 grams. Okay, so I would like you to pause the video, try to work through this, and then we'll work through it together. Okay, so how many moles, so question mark is moles, are present in 146 grams of glucose? When I get a problem like this, I like to put the question mark, put what we have, and then actually like physically draw an arrow to say what we're going to be doing. And when you do it that way, it helps you keep track in your mind of where you're starting and where you're going, what they're actually asking for. So step 1, we're going to put down the 146 grams of glucose. And since we have grams on the top, we're going to put grams on the bottom. We're going to put moles on the top. 1 mole is equal to the calculated mass from the periodic table. So now we actually have to calculate out the mass. So in this formula, there are 6 carbon. So carbon, hydrogen, oxygen. We have 6 of the 12.01, and we're just going to use the masses that they give us here. Then we have 12 hydrogen, so we're going to do 12 times 1.01. Then we have 6 oxygen, so that's 6 times 16. So when you add these up, parentheses 6 times 12.01, close the parentheses, plus parentheses 12 times 1.01, close the parentheses, plus parentheses 6 times 16, close the parentheses, 180.18. So now we're going to multiply across the top, divide away the bottom. So 146 divided by that 180.18 gives us 0.810 moles. So this is the correct answer. All right, I would like you to pause the video and work through these 2 problems, and then we'll unpause and work on them together. Okay, how many moles, question mark, moles, are present in 34 grams of that? So we have that, and we want to convert to our question mark. So 34 grams of that substance, and you can definitely write that all out. It's just hard for me to write it with the pen on the computer screen. So we'll just have a mutual understanding that we're talking about that compound. So we've got grams on the top, grams goes on the bottom, and we're converting to moles. So we're going to put moles on the top. Now our conversion factor is 1 mole is equal to the mass from the periodic table. 1 mole is equal to this mass. So we actually have to figure out what the mass of this is for 1 mole. So this has copper, oxygen, and hydrogen. So there's 1 copper, and copper is 63.546 grams per mole. Then we have 2 oxygen, then we have 2 hydrogen. So when we put this all together, $97.56 grams. So 1 mole is equal to the mass from the periodic table. That's the mass we just calculated. 97.56 grams. So just like any unit conversion, we're going to multiply across the top and divide away the bottom. 34 divided by 97.56 gives us we'll just round it to 0.35 moles. So that's our final answer. So now we have, what is the mass? Sorry about that. What is the mass? So question mark, grams of 4.2 moles. So we're converting that way. So 4.2 moles since moles is on the top, moles has to go on the bottom. And we're converting to grams. So 1 mole is equal to the calculated mass from the periodic table. So we actually have to calculate what this mass is. So we have Ca, N, and O. There's 1 calcium, and calcium is 40.078. Then we have 2 nitrogen, and nitrogen is 14.007. Then we have 2 times 3 to give us 6 oxygen. And we're going to add all that up. So in the calculator, 40.078 plus parentheses 2 times 14.007, close parentheses, plus open parentheses 6 times 15.999, close parentheses, 164.086. So that's the grams per 1 mole. So we're just going to put that in over here, 164.086. Now we're going to multiply across the top and divide away the bottom, and we end up with 689.16.